Good morning, class. Let us see some examples which are remaining of the Laplace transform property, that is Laplace transform of integration. So the property is Laplace transform of integration from 0 to t ft dt equal to Laplace of ft upon s. So these are some examples. So let us see this example. Find the Laplace transform of triple integration from 0 to t. There is three signs of integration. So this type of integration is called triple integration. So Laplace transform of integration from 0 to t cos at, and as there are three signs of integration, so with respect to t variable there are three notations, that is dt, dt and dt. So we have to find Laplace transform of this integration. So we have the property that Laplace transform of one time integration ft dt is equal to Laplace of ft dividing by s. So this is the different example because we have to find the Laplace transform of triple integration. So for one time integration, while we find the Laplace transform, there is a s term in denominator for the one time integration and Laplace transform of that one time integration. The answer is, we have to find the Laplace transform of ft dividing by s only. So you can remember this property as one time integration, so there is a one single variable s in denominator. So for three times integration there will be three times s, that is s into s into s should be in denominator. So this property is for one time integration and we have to apply this property for three times integration. So one time integration property we have to apply three times for this three times integration of this Laplace transform example. So here first find Laplace of ft, and ft is the function which is under the integral sign. So under the integration sign there the function is cos at. So find the cos at Laplace. So cos at Laplace, this is the standard direct formula of Laplace transform. Cos at Laplace is s upon s square plus a square. So put this value of Laplace of ft, that is cos at, this answer in this property we get s upon s square plus a square upon s, that is s upon s square plus a square into 1 by s. So this is the answer of one time integration. So by simplifying we get s get cancelled, we get 1 upon s square plus a square. So for second time integration, as we know that we found the Laplace of ft, second time integration the Laplace of ft is same, that is cos at Laplace is s upon s square plus a square. So while we put this s upon s square plus a square, that is Laplace of ft here, second time again we have to divide by s. So for first integration we dividing by s for Laplace of ft. By simplifying we get the simplified answer. Then second time integration again divide by s to that first answer of this Laplace of integration. So this is your answer, 1 upon s into s square plus a square. Then for third time integration again divide by s. So here we get the final answer of this required example, that is 1 upon s square into s square plus a square. That is this type of example if we ask in exam. So for first time integration dividing by s, so this is the common term, that is Laplace of ft. So find the ft Laplace, that is ft is your the function or the term which is under the integration sign, that is cos at is your ft. Find its Laplace transform, and then whatever times you ask the integration. So if we ask one time integration for Laplace transform, then dividing by only one s variable. If we ask two times integration for Laplace transform, then divide by s square, that is s into s, two times we have to divide s, that is s square. And then for three times integration we have to divide by s cube. So by simplifying we get For one time s, this and numerator s will be cancelled, and this is your second time dividing by s, and this is your third time dividing by s. So for third time integration, to find the Laplace transform, we have to divide by 3 times s. 3 times s, that is s cube, we have to divide by s cube for Laplace of ft. So this is your final answer. Next example is Laplace transform of integration from 0 to t e raised to minus t sin 4t. That is, this is your regular example, that is you have to find the Laplace of one time integration. So property is find Laplace of ft and dividing by only 1s. So this is your ft. So find its Laplace transform, that is Laplace of t e raised to minus t sin 4t. So this is equal to Laplace of ft is your the term under the integration sign. Under the integration sign, this is your term. So this is your ft. So t, because under the integration sign, this is your property and this is your example. So 2 points are common in any property of Laplace transform, that we have to compare from left side, and whatever we get, the values we have to put in RHS of that property. So by comparison, this is your left side of this property and this is your example. By comparison, we get 0 to t, 0 to t. Here the term is ft, here the term is t e raised to minus t sin 4t. So we get ft equal to t e raised to minus t sin 4t. So we get the ft value. So put that ft value in the right side of this property. So we get Laplace of t e raised to minus t sin 4t and upon s. So this is your final answer. So just we have to find this numerator. So as these types of examples we have studied or we have solved in previous lectures, so you can easily get the answer of this Laplace transform by seeing these examples. So for 3 terms, that is if the 3 terms are in multiplication form and if exponential function is present, this is your exponential function e raised to minus t. So if exponential function is present, then take at the first position. So Laplace of e raised to minus t t sin 4t, and then apply, this is your numerator. So for finding the numerator value, Laplace of take e raised to minus t at the first position, so we can easily get the answer in minimum step. So Laplace of e raised to minus t t sin 4t. So apply here shifting property, because exponential function is given in this term. So to find the Laplace transform of this term, we have the shifting property. So shifting property is Laplace of e raised to minus at ft is equal to, first find ft Laplace and then put the substitution s equal to s plus a. A is your number which is multiplied to t in exponential term, and ft is your the function which is multiplied to exponential function, that is your ft value. Find its Laplace transform and then put the substitution. So here, to find the numerator value, we first apply the shifting property, because we have taken e raised to term at the first position. So apply shifting property, this is your shifting property. So to apply this property, again compare this left side with this example or this numerator. We get ft is t sin 4t. So put this ft value here on RHS. So we get Laplace of t sin 4t with substitution s equal to s plus a. A is your number which is multiplied to t. Here number which is multiplied to t is 1. So put a equal to 1. So we get s equal to s plus 1. So by shifting property, the numerator answer is this, Laplace of t sin 4t upon Laplace of t sin 4t with substitution s equal to s plus 1. Again solve this numerator in this property. So for Laplace of t sin 4t, we have to recall the multiplication by t property. So multiplication by t property is Laplace of t raised to n ft is equal to minus 1 raised to n nth derivative with respect to s of Laplace of ft. So this property again we have to apply for finding this numerator of this main numerator value. So to find this main numerator from equation 1, we use the shifting property. And in shifting property, we get this equation number 2. In this equation number 2, again we get the Laplace transform of t sin 4t, which is your numerator. And it is the unknown term. We have to find out this numerator first. And to find this numerator in this equation number 2, we applied multiplication by t raised to n property. So to apply this property, multiplication by t raised to n property, to this numerator in equation 2, again compare this left side. So n value is here. The t raised to power is nothing, that is power is 1. So n value is 1 and ft value is your sin 4t. So put n value and ft value in this right side of this property. So we get required equation number 2 answer. So equation number 2, that is n equal to, its Laplace of t sin 4t answer is by this property minus 1 raised to n value is 1, first derivative of Laplace of ft. Ft is your the term which is multiplied to t. Sin 4t is multiplied to t, so ft is your sin 4t. And with and this is your answer of this numerator, and substitution right as it is. We have to put this substitution at the last. So simplify this. Minus 1 raised to n is minus 1. This is your step. Minus 1 raised to n is minus 1 d by ds of sin 4t Laplace. So sin 80 Laplace is, this is your standard formula of Laplace transform. Sin 80 Laplace is a upon s square plus a square. So sin 40 Laplace is 4 upon s square plus 4 square, that is s square plus 16. Then take the derivative of this 1 upon s square plus 16. As 4 is number which is constant, take outside. So minus 4 d by ds, that is first derivative of 1 upon s square plus 16. So for 1 upon derivative, we use the original formula 1 by x. So 1 by x derivative is minus 1 by x square. So instead of single variable, there is a term s square plus 16. That is, instead of x, there is another term s square plus 16. So use bracket formula. So 1 by bracket derivative is minus 1 upon bracket square into common term derivative of brackets. So minus 1 upon bracket square b square s square plus 16 into derivative of b. 1 upon b, and here we have to apply this formula for 1 upon s square plus 16. So b value is your s square plus 16. So multiply derivative of b. So derivative of this b is s square derivative is 2s, 16 derivative is 0. So we get derivative of s square plus 16 is 2s. Simplify this, minus minus plus 4 into 2, 8. 8s upon bracket square. So this is your answer of this numerator in equation 2. Then put this value in equation 2, we get the numerator answer. So numerator is your Laplace of e raised to minus t, numerator of equation number 2. So Laplace of e raised to minus t t sin 4t equal to, its answer by multiplication by t raised to n property is 8s upon bracket square, and this substitution right as it is, s is equal to s plus 1. Then put s equal to s plus 1, 8 into s plus 1 upon s plus 1 bracket square plus 16 bracket square. So this square we have to expand. So 8 into s plus 1 by using a plus b bracket square. A square plus twice ab, that is 2s plus 1, and this plus 16. So merged this plus 1 and plus 16, we get plus 17 bracket square. So this is your equation number 2 answer, that is Laplace of e raised to minus t t sin 4t, and this is your numerator of equation number 1. So put this value in equation number 1, we get the answer of the required example. So required example answer is, this value we have to put here and by dividing by s only. So dividing by s, we get the final answer. Next example is Laplace of e raised to minus 4t into 0 to t sin 3t upon t dt. Here there is a product of two terms. First term is exponential term e raised to minus 4t, and second term is integrative term 0 to t sin 3t by t dt. So here you can see as a second term, this integration is your second term and this is your first term. So there is a product of two terms. In these two terms, one term is exponential function, and if in product of two terms one function is exponential, then apply shifting property. So by shifting property is Laplace of e raised to minus at ft dt. So here Laplace of e raised to minus at, just we have seen this property in previous example. So Laplace of e raised to minus at ft is equal to Laplace of ft with substitution s equal to s plus a. So here e raised to minus at, so a value is 4. Here a value is 4. And ft means the term which is multiplied to exponential function. So this integration, this term is multiplied to exponential function and this is your ft. So to apply this shifting property, again there are two common steps. That is, first compare this left side with this example. You take as e raised to minus 80, e raised to minus 40. So we get a equal to 4 by comparison, and ft value is your this second term, that is integration. So ft is your integration term and a value is 4. So we get by comparison of left side, we get a value and ft value. So put these two values in RHS of this property, we get the required example answer. So this required example Laplace transform equal to, put ft value in the property. So Laplace of integration of ft is your 0 to t sin 3t by t dt, and with substitution s equal to s plus a value is 4, s plus 4. So this is your equation number 1. So in this equation number 1, the numerator is unknown, that is you have to find the numerator first. So in numerator, so for numerator is Laplace of 0 to t sin t by t dt. So here again, to find the Laplace transform of this integration, that is to find its numerator value of equation 1, we have to apply again the previous property, that is Laplace of integration property. So Laplace of integration property is Laplace of integration from 0 to t, limits are same. So you can apply this property. Laplace of integration of ft dt equal to Laplace of ft upon s. So again we have to compare this left side with this numerator. So ft value is sin t by t, and put this ft value in this property, in this RHS of this property, we get the answer of this numerator. So this is equal to, put ft value here, that is ft is your sin t by t. By comparison of left side with this example or with this numerator, we get ft is sin t by t. Put this value sin t by t in this RHS of property, and that answer we have to write here, which is the answer of your numerator. So Laplace of ft value is sin t by t upon s. So this is your answer of this numerator. You can write this as equation number 2. So in equation number 2, again there is a numerator, that Laplace of sin t by t, and its value we have to find. So again consider Laplace of sin t by t. So for this, if we see sin t by t is present, so in numerator t is present, that is we have to apply the division by t property here for finding the Laplace of sin t by t. So division by t property is Laplace of ft by t is equal to integration from s to infinity Laplace of ft ds. So again, to apply this division by t property, again two steps we have to write here, that is comparison of left side and substitute the values in RHS. So by comparison of left side, we get 1 by t, that is ft value is sin t. So put this ft value in this RHS, and that is your answer of this Laplace. So integration from s to infinity, Laplace of ft value is sin t ds. So simplify this. So before finding the integration, we have to take first Laplace of sin t. So sin 80 Laplace is a upon s square plus a square. Sin t Laplace is a value is 1. So 1 upon s square plus 1. 1 upon s square plus 1, this integration we have seen in previous lecture. That is 1 upon in this example, actually we have seen that sin 3t is there. So you can take as this is sin 3t, sin 3t, sin 3t, sin 3t. So sin 3t Laplace is, sin 80 Laplace is a upon s square plus a square. Sin 3t Laplace is a value is 3. So 3 upon s square plus 3 square, that is 9. So this is your s to infinity, this step s to infinity 3 upon s square plus 9 ds. So take 3 outside and take the integration of 1 upon s square plus 9 by using 1 upon x square plus a square integration formula. So 1 by a tan inverse x by. So here a square, then take a in answer. So here 9 is there. So this is your a square value. So a value is 3. Take the square root. A square value is 9. X square variable square. Here variable is s. So variable square, variable square. Instead of a square, we have given 9. So a square value is 9. So from that, a value is 3. So put a value here. So 1 by 3 tan inverse s by 3 from s to infinity. So 3 get cancelled. Put tan inverse infinity by 3, that is tan inverse infinity pi by 2 minus put s equal to s, that is minus tan inverse s by 3. So you can write this answer as it is, or you can take the formula or apply the formula. Pi by 2 minus tan inverse x is cot inverse x. So we get cot inverse s by 3. So cot inverse s by 3, this is your answer of sin 3t by t. And put this Laplace of sin 3t by t, this answer in this equation number 2. So we get cot inverse s by 3, cot inverse s by 3 upon s. Cot inverse s by 3 upon s. This is the answer of your equation number 2. Then what is the required answer? And this is your equation number 2 answer. And this Laplace answer is your numerator of this equation number 1. So its answer is cot inverse s by 3 by s. This is your answer of this numerator. So put this answer in this equation number 1. We get the required Laplace transform answer. So Laplace of e raised to minus 4t integration sin 0 to t sin t by t dt equal to, the answer is put here. So we get cot inverse s by 3 by s with substitution as it is s equal to s plus 4. In example, whatever the substitution, that step we have to apply at the last, that is substitution step. At the last step we have to apply or we have to substitute that term. So put s equal to s plus 4. So we get cot inverse s plus 4 upon 3 upon s plus 4. So this is your answer of this example. This is different example because there are two terms which are in multiplication form. One term is exponential function and second term is your integration function. So here we have applied if product of two terms are present in example and one term is exponential function, so apply first shifting property. So in this shifting property, when we apply shifting property, for this numerator value we have to take the Laplace of integration property, or we have to apply Laplace of integration. And for Laplace of integration we have to apply division by t property. So here we have applied 3 properties at a time. So in many examples we have to apply more than one property. Some examples, these examples are minimum in your syllabus, that the examples are there that we have to apply only one property, but in many examples we have to apply more than one property, that is 2 properties, 3 properties, etc. So we have to study all these properties of Laplace transform. So these are the important properties. Next is this example you can see as a special example, that is Laplace transform of error function of root t. So this you can remember as a special example, that is we have to find the Laplace transform of error function. So this error function is defined in the form of integration. So this you have to remember as a formula. So error function is denoted by ERF. So error function of root t is equal to 2 by root pi integration from 0 to root t e raised to minus x square dx, that is 2 by root pi 0 to root t, and this upper limit is we have to take here for defining error function of upper limit, that is error function of root t 0 to root t e raised to minus variable square dx. So this is your error function formula, and we have to remember this formula. And here the question is we have to find the Laplace transform of this error function. So take the Laplace transform on both sides. So this formula we have to remember, ERF root t equal to 2 by root pi integration from 0 to root t e raised to minus x square dx. So take Laplace transform on both sides. So Laplace of ERF root t, which term we have to find, is equal to take Laplace transform on RHS simultaneously. So 2 by root pi is constant, take as it is, and take the Laplace transform of integration from 0 to root t e raised to minus x square dx. So this term is unknown, we have to find further. So here we have seen one property, that Laplace transform of integration, but in that integration the limits are fixed, that is limits are from 0 to root t, and in this example we have asked for 0 to root t Laplace. So we can't apply that property, Laplace transform of integration from 0 to t. That property we can't apply here. So here we have to change this upper limit, as it is fixed that this step is fixed that we have to find Laplace transform of this integration. But there is one problem, that the upper limit is different, that is in that property, that is Laplace transform of integration, in that property the limits are 0 to t, then only we can apply that property for finding the answer of given example. But here, as we have to find this Laplace transform but limits are different, that is 0 to root t, as in other example if it is given that 0 to t, then we can find the Laplace transform of this function by using that property. But here the limits are not same. Instead of 0 to t, we have given 0 to root t. So first we have to change this upper limit. So how to change this upper limit? There is one method in integration, that is we have to use the substitution method. So that in that substitution method we can change the limits of the given integration. So to change this limit we have to use this substitution, and this is your substitution. So remember the substitution. Put x square equal to t. Here x square is present, so put x square equal to t. In substitution method, the next step is we have to take the derivative on both sides. So x square derivative is 2x dx, x square derivative is 2x dx with respect to x, and t derivative is dt. So these are the steps in substitution method in the integration chapter. So to have the upper limit as t, we use the substitution method. And for substitution method, we have to substitute some terms for the another variable. You know the substitution method in integration. So put x square equal to t, then take the derivative separately with respect to x and with respect to t. X square derivative is 2x dx, t derivative is dt. Then we have to put dx value here. So take dx equal to dt upon 2x. Change this x variable. So dt upon 2, as x square is t, then x is, take square root on both sides. So x is root t. So dt upon 2 root t. Why we have done this these steps or this conversion? Because when we use the substitution method for finding the answer of integration, whole integration we have to convert in the another variable, that is here we have taken the t variable. So convert this whole integration in t variable so that we can solve the integration. So put x square equal to t, then from this take the derivative on both sides and find the value of dx in terms of t variable. dt upon 2 root t, that is half dt, root t is t raised to half, and take this t raised to half in numerator, so we get t raised to minus half, that is positive power changes to negative, so t raised to minus half. Then for substitution method we have to check the limits also. So these limits are, as this is the integration with respect to x, so these limits are for x, so x equal to 0 and x equal to root t, we have to find the t value. So put x equal to 0, in this substitution we get 0 square, that is 0, t equal to 0, and put x equal to root t here, root t square, that is square root and square get cancelled, we get t equal to t. So for x equal to 0, t is 0, for x equal to root t, t equal to t from this substitution. So Laplace of root t equal to 2 by root pi, as it is Laplace of 0 to root t x limits changes to 0 to t for t limits. So 0 to t, e raised to minus x square is your t, e raised to minus t, and dx value is your this half dt, t raised to minus half. This 2 get cancelled, so we get 1 by root pi Laplace of 0 to t, e raised to minus t, raised to minus half dt. So here this Laplace transform of this integration we can find by using the previous property, because here the limits are matched, that is in that property the limits are from 0 to t, and by using substitution method we changes 0 to root t limits as 0 to t, so that we can apply that property. So what is that property? Laplace of integration from 0 to t is Laplace of integration from 0 to t ft dt is, take Laplace of ft in numerator and divide by s only. So its answer is Laplace of ft. Ft is your function under the integration sign, and this is your ft, e raised to minus t, raised to minus half. So its answer is Laplace of ft. Ft is e raised to minus t, raised to minus half dividing by s. This is your answer of this equation number 2. And in this answer numerator is unknown, so we have to find here numerator. So numerator is Laplace of e raised to minus t, raised to minus half. So use here shifting property. For shifting property, whatever the function which is multiplied to e raised to term, that is your ft. So find Laplace of t raised to minus half, and for shifting property use the substitution s equal to s plus a. Here a value is 1, so put s equal to 1, s plus 1. Again in that we have to find Laplace of t raised to minus half. So we have solved separately. So Laplace of t raised to minus half, for this we have to apply the t raised to fractional power, t raised to n. So this is the separate formula, that is t raised to Laplace of t raised to n. So two formulae are there for Laplace of t raised to n, that is in factorial form and in gamma function. That is for t raised to n, here t raised to n, when n is whole number, that is not fractional number, then factorial formula is n factorial upon s raised to n plus 1, and for fractional number t raised to n Laplace is gamma n plus 1 upon s raised to n plus 1. So here Laplace of t raised to n, that is n value is minus half, and the formula is gamma. This is your gamma notation we have studied in first 2 lectures. So gamma n plus 1, that is minus half plus 1 is half, gamma half upon s raised to n plus 1, that is same number, that is s raised to half, and gamma half value is fixed. This is you can remember as a formula. So gamma half equal to root pi. So root pi upon s raised to half means root s. So root pi upon root s, this value is your Laplace of t raised to minus half. Put this answer in this. So we get root pi upon root s with substitution s equal to s plus 1. So this is your answer of this Laplace of e raised to minus t raised to minus of e raised to minus t raised to minus of Laplace is, this is your numerator answer, root pi by root s, and with substitution s equal to s plus 1. So put s equal to s plus 1, we get this answer. And this is your answer of this equation. So put this Laplace answer, this is answer, after substitution we get this, and this is your answer of this e raised to minus t raised to minus half Laplace, and dividing by s we get the required equation number 2 Laplace. So put this value here and put this value here with 1 by root pi as it is, and its required Laplace is root pi upon root s plus 1. This is your Laplace of ft. Ft is your e raised to minus t raised to minus half, and dividing by s we get the required answer. Root pi upon root s plus 1, this is your answer, and dividing by s we get the required answer. So this is your Laplace of ERF root t. Next is, next three properties are different from the previous properties. In first lecture we have seen the Laplace transform of some functions by using the standard formula of Laplace transform. Then one by one we use the properties of Laplace transform, that is shifting property, then change of scale property, division by t property, multiplication by t property, Laplace transform of integration. So these are some properties we have studied in till the lectures, but from further there are three types or three functions, special functions. For that we have to find the Laplace transform, and the of course the formulae for these functions are different from the previous formulae. So in that this part is different from the previous part. From this you have to study the three functions: periodic function, Heaviside function, Dirac delta function. So these are the further three functions for which some examples are there, that we have to find its Laplace transform by using their formulae only. So there are special separate formulae for these functions: periodic function, Dirac delta function, and Heaviside unit step function. So first function is Laplace transform of periodic function. So formula is fixed. So Laplace of ft is equal to 1 upon 1 minus e raised to minus s capital T integration from 0 to capital T e raised to minus st ft dt, where f of t plus capital T equal to ft, that is t is your capital T is period of ft. So if ft is your periodic function, and for periodic function the definition is given, if ft is periodic function, then we have f of t plus t equal to ft, and in that the capital T is period of that function ft. So this is your Laplace of periodic function ft, and this is the separate formula for periodic function. So you can see the examples in next lecture. Thank you.